Okay, so let's go through perpendiculars and distance. The author states the distance from a line to a point not on the line is the length the distance, keyword distance, the distance from a point, from a line to a point not on the line is the length of the segment perpendicular, just use the symbol for perpendicular, to the line from the point. And they will give you examples. Say on this example they ask you to draw a segment that represents, the distance from, and you got to read this real carefully. On this one, draw a segment that represents the distance from point P to line AB. And you can tell it's a line because they've got the symbol up above it. Okay? And let's say they give you this as an example. They give you a triangle that looks similar to this. Okay, and label this is A, this is B, and this is P. Okay. Now they're saying line AB. Okay, so you have to look at this. Right now it's a segment AB, but you got to think of it as a line through point A and point B. Okay. The distance from point P to AB is actually the perpendicular. Okay, so it's the perpendicular down to here. Okay. So this represents the distance from point P to line AB. It's the perpendicular, and you'd have to figure out what is the length of that. They'd have to give you enough ordered pairs that you could find that. Okay? Let's try another one. This time they're going to change the directions. Draw a segment that represents the distance. Now you got to read it carefully. From, on this one they're going from point A to line PB, and it's a line, not just a segment. Okay. On this one, here's the beginning. Okay, this would be point P up here. This one is A, and this one is B. Okay. Now, it's the distance from A to PB. So it's got to be a perpendicular from point A. It's got to be from here and then perpendicular to this line. Okay. So perpendicular to this line is going to go about right here. It's got to be a 90-degree angle. So, and they would have to, we've drawn the segment. They would have, you'd have to have enough that you'd have the ordered pairs. But right now, they're just wanting that segment. So it's got to be a perpendicular distance. Okay. Is that okay with everybody? Okay, so you extend that line PB and then draw a perpendicular. Okay. We're just drawing the sketch. If I was doing it exact, I'd have to do a compass and a straight edge and do a construction. And I'd have to make it perpendicular by constructing it that way. Yeah. Okay, now let's go through an example where we actually use the numbers. Okay. And I'm going to skip to a full page. Okay. Okay. Say they ask you to find the distance. Keyword distance. Find the distance between parallel lines. Just use the symbol for parallel. Parallel lines whose equations are, okay, now we have two equations for the parallel lines. One is y equals a negative 1/3 x minus 3. Okay, that's one equation. And y equals, now what do you know about parallel lines? What about their slopes? They have to be the same. So this one is also a negative 1/3 x plus 1/3. Okay, so we have two equations, this one, okay, and this one. Okay, we want to find the distance between those two lines. Okay, okay, so we're going to do a sketch first. Okay, let's do a sketch. Yep. So graph both lines first. Okay, the slope of both these lines is a negative 1/3. And what's the perpendicular slope then? 3, or 3 over 1. Yep. Okay, so let's graph both lines. Okay. On the first one, it's going to cross. Remember, you graph the b value first. Okay, so it's going to cross at negative 3. Plot a point. The slope, this is the rise over the run. So from that point, we're going to go down 1, and then we're going to go to the right 3 and plot a point. Okay? Or you can go up 1 and to the left 3 and plot a point. So you should get a line similar, or should hit that point to that. Okay, and I would label that on your picture. This line is the y equals a negative 1/3 x minus 3. Okay, now graph this one. This one crosses the y-axis at 1/3. So if this is 1, we're just going to estimate that this is 1/3. Okay, you would still do the same thing. This is rise over the run. So from that point, you're going to go down 1, so it's right here, and then go to the right 3. And you do the same thing. You go down 1 and to the right 3. Okay, or you can go up 1, would be about right here, and go to the left 3. And they should look close to parallel. I can do better. Hang on, I can do better than that. Close to parallel. This one, label it y equals a negative 1/3 x plus 1/3. Okay. Okay, now you pick one of those lines, and the easiest one to pick is probably going to be this one, because we have a point. We know the point where this line crosses the y-axis. What is this ordered pair? 0, negative 3. And if we want to find the distance between those two lines, we have to find, we already found a perpendicular slope. So we want to go from this point and go perpendicular to this other line, and we want to find an ordered pair over there. Okay? Make sense? Yes? Okay. Okay, so if we look at this to find the equation, we need to find the equation of this line. When they say find an equation of a line, what two things do you need? Y-intercept and slope, or point slope, right? Okay, so if I go to y minus y sub 1 equals m times x minus x sub 1, okay, and I'm trying to find the equation of this line coming through here, okay? I know the slope of that line. You told me the slope of that line was 3. You told me a point on that line is 0, negative 3. So I can sub in y minus a negative 3 equals 3 times x minus 0. All right? Minus a negative, same thing as plus 3. Okay? And then I'd have y equals, take the 3 to the other side, so I'd have y equals 3x minus 3. Okay? Now I know the equation of this line is y equals 3x minus 3. Okay? I still need, I'm working to find out what's that ordered pair. Okay? Isn't that ordered pair on both lines? It's on, the ordered pair is on, it's on this line and it's on this line, right? Okay, so it's on both lines. You agree that y equals y? Because it's the same ordered pair, right, on both lines? So this y value, 3x minus 3, and it's on this line, right? Negative 1/3 x plus 3, plus 1/3, sorry, plus 1/3. You agree that those y values, that ordered pair is on both lines, so the y values have to be the same on both lines. So set y equal to y. Okay, and then sub in, and now solve. How can I get rid of the fractions? I don't like them. Multiply by 3. Okay, so let's multiply by 3. I may end up with fractions, but I'm going to get rid of them to work this. So when I multiply by 3, they give me 9x minus 9. What's a third of 3? 1. And then I have a negative times a positive. So it'd be negative 1x. Check my arithmetic. And then a third of 3 plus 1. You agree with that? Okay, and then solve for x. Get the x's together. I'm going to add 1x, add 1x. So 10x minus 9 equals 1. Get the 9 over to the other side. Add 9. So I'd get 10x equals 10. So x equals 1. Okay? So that's 1. X equals 1. Okay? So now we need that ordered pair. Okay? If you substitute that back in to either one of the originals, and I don't want to do the one with fractions. So if I put 1 back in there, 3 times 1, 3 minus 3, 0. So this ordered pair, I now figured out this ordered pair is 1, 0. Now I have enough to figure distance. Distance, I have to have 2 ordered pairs. Okay, so now I use the distance formula. Distance equals square root of x sub 2. Make sure you write it as a subscript. Don't write it this way, x2. It's x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. We have 2 ordered pairs. We've got this one and we've got this one. Okay? Label either one of them. I labeled, I guess when I did this, I labeled this one is my x sub 2, y sub 2. I labeled this one. It doesn't matter. So I ended up with my x sub 2 was 1. My x sub 1 was 0. My y sub 2 was 0. My y sub 1 was negative 3. Okay. Keep your equal signs all the way down. Extend that square root out. So this would be 1 squared plus minus a negative. Same thing as adding a positive, so that'd be 3 squared. So you'd end up with square root of 1 plus 9. Square root of 10. Okay, and then if you did that on the calculator, I think they will probably take it out on the calculator to the nearest tenth, I think. You'll have to look at the directions. If you do the square root of 10 on the calculator, and then they're rounding it to 3.2. Okay? Okay? Depends on the directions. If it says round it to the nearest tenth, then you got to take it on that. Okay? Okay, let's try one more. One more example. Okay. Is that enough time on that one? Okay. Okay, say they ask you to find the distance between, and use the symbol for parallel, between the parallel lines whose equations are, okay, here's our two equations. Y equals 2x plus 3 and y equals 2x minus 3. Slopes have to be the same for them to be parallel. Okay, and their directions say round the distance to the nearest tenth. Okay, so first let's get a picture. Okay, remember when you graph, you're going to graph the b value first. So graph crosses at positive 3 and put a point. Slope is 2 or 2 over 1. That's rise over run. So you're going to go up 2 and to the right 1. You're going to go up 2 and to the right 1. Or you're going to go to the left 1 and down 2. Left 1 and down 2. Oops, that should not be so far down. So you should end up with a line. And remember, anything that's in a positive slope should tilt that way. Okay? And I would label it. This one is y equals 2x plus 3. Okay, then graph the other one. Y equals 2x minus 3. So graph the b value first. It goes through at negative 3. Slope still 2 over 1, so go up 2 and to the right 1. Go up 2 and to the right 1. And up 2 and to the right 1. So it should look something, they ought to look parallel, close to it anyway, on your picture. And label that one. That one is the y equals 2x minus 3. Okay? Now, you may pick either one of these because both of them go through, okay, not at a fraction. Okay? I actually picked this one because it didn't have a negative. Okay? So I know this ordered pair is 0 to the right and up 3. Now, you got to take your time on that. Don't write it 3, 0 because that messes up your whole thing. It's 0 to the right and up 3. Now, you need to figure out a perpendicular, okay? And you got to figure a point over here. Okay? So, if our slopes up here are 2, what's the perpendicular slope? Negative 1/2, the negative reciprocal. Okay? Okay, and I know I want to find the equation of this line right here. So I have a point already and I have a slope. Go to point slope form of a line. So go to y minus y sub 1 equals m times x minus x sub 1. I got to find the equation of that line. So I'm going to use the ordered pair 0, 3. So it's y minus 3 equals a negative 1/2 and x minus 0, right? So I got y minus 3 equals a negative 1/2 x. Okay, and add 3, so y equals a negative 1/2 x plus 3. Okay. Which I could have actually gone to slope-intercept form. I could have done this too, right? Y equals mx plus b. I know the slope and I know the y-intercept. I could have gone right to this. That would also work. Okay. Either way, I get the same equation. Okay, now I've got that equation, and I'm working with this point. Okay, and I need to find out what this ordered pair is down here. I need to figure out what that ordered pair is. Okay. Okay, that ordered pair is on both this line and this line. Set the y's equal. Okay, so set y equal to y because they're the same ordered pair, so the y's have to be equal. So set 2x minus 3 equal to a negative 1/2 x plus 3. If you want to, you can get rid of the fractions. What can I multiply by? 2 on both sides. Yeah, either way. So if I have 4x minus 6, remember you got to distribute that. It's got to be times both of them. And what's half of 2? So negative 1x plus 6. Get the x's together. Now some of you may be at that stage where you can do that step by sight. If you can, that's okay. If I add 1x to both sides, if you can do that by sight and not miss it, that's okay with me. And then take the 6 to the other side, add 6. 5x equals 12, divide by 5. Am I wrong because I'm going to get a fraction? No. X is 12/5. Okay, now I have to figure out what y is. Okay, put it back into either one of the originals. I'm probably going to go back to this one over here. So if I have y equals 2x minus 3 and my x is 12/5, I'm multiplying. So I end up, I can't reduce anything there, but I can multiply, I get 24/5. 3 is the same thing as 3 over 1. 3 is how many fifths? 15. So that'd be 15. 24/5 minus 15/5. 9/5. Okay, so now I know my ordered pair. Okay, so this point is 12/5, 9/5. Okay, so now I know this ordered pair and this ordered pair. Now I go to the distance formula. Okay, so distance, x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared, and the square root of that whole thing. Okay, and I used, I labeled this one as my x sub 2, y sub 2. The other one, 0, 3, I labeled that as my x sub 1, y sub 1. Okay, so when I fill in, I've got 12/5 minus 0, quantity squared, plus 9/5 minus 3, quantity squared. Then I got to simplify that. 12/5 squared. What's 12 squared? 144. 5 squared? 25. Plus, now this is like 3 over 1. 3's how many fifths? 15. So this is like, all I'm doing is I'm multiplying this 1 by 5 and multiplying the top by 5. You got to multiply both these by 5. Okay, so 9/5 minus 15/5 would be, okay, So it would be plus a negative 6/5 squared. What's a negative 6 squared? 36. So I've got 144/25 plus 36, and 5 squared is 20. Okay, and then keep going. 144 plus 36, 180 over 25. Okay, and then I would go right to the calculator, because they're saying go to the nearest. You don't have to take out 5. Just go right to the calculator. And if you did this one on the calculator and round it, it's going to end up to be, they have 2.68, but they want it to the nearest tenth. So if that's 5 or greater, you're going to round that up. So final answer is 2.7. Okay? 2.7 is the final answer. So to figure distance between two parallel lines, okay, you got to figure the perpendicular slope, okay, which we did up here. We figured the perpendicular slope. Then we had to find the equation of this perpendicular line. Okay, you always have a point. Pick a point on the y-axis where it crosses, and the slope. You'll find the new equation of the line. Set those y values equal. That's why I graph it. So I didn't use this equation. I used this one. Okay, because I know it's this ordered pair right here. Okay. Find the ordered pair, and then you can go to the distance formula. Okay, that should be enough to get you started.